Hello, welcome for our science lesson. We are proceeding with the topic of rocks, and in the previous lesson we were looking at the sedimentary rocks and how they are formed, including the various processes over which they are formed. This time we are going to look at metamorphic rocks. And after sedimentary rocks have been also formed, I'll just preview shortly. We learned that there are some changes that normally occur in the rock. For example, after they have been weathered down, the debris have been carried and deposited down in strata, the changes will occur on the strata for a period of time. As such changes occur as a result of heating and pressure that is caused by igneous activities. This leads to the formation of the metamorphic rocks. Then, what are the metamorphic rocks? Metamorphic rocks are the rocks which have been formed and have been modified by heat and pressure. Considering their chemical change have occurred, and that one will give a simply new characteristic of a rock. Let's go back to the previously formed rocks such as igneous rocks. The igneous rocks and sedimentary rocks. When these rocks have already been formed, it is the products of the igneous as a result of weathering. As a result of weathering, they are laid down in strata. When they are laid down in strata, they will be subjected to great heat and pressure. They will be subjected to great heat and pressure. When they are subjected to pressure, and then they are going to be metamorphosed into a new structure of a rock. That kind of a rock, we call it metamorphic rock. And the process under which this type of rock has undergone or has been changed, we will say that the rock has been metamorphosed. The rock has been metamorphosed. The word metamorphosed means the change of the characteristic and the appearance, including also the chemical composition of the rocks. Therefore, we are going to look at how metamorphic rocks have been formed. How are metamorphic rocks formed? We are going to look at the formation of the metamorphic rocks. Already we have seen these rocks have been formed as a result of them being subjected to great heat and pressure. And then after a period of time, they are going to be metamorphosed into new structure, and that is a new rock that will appear. That rock, we call it metamorphic rock. There are actually three basic ways through which these kind of rocks are formed. And one way in which these rocks are formed, they are formed from the ones formed igneous rocks. We call them, they are formed from the ones igneous. We have igneous rocks and sedimentary rocks, igneous and sedimentary rocks. What happened from these ones already formed igneous and sedimentary rocks? These igneous and sedimentary rocks, upon weathering, they are being subjected to great heat. When they are subjected to great heat and pressure, relatively heat changes the chemical composition of the mineralogy or the content that are found in the rocks, and that one will also make the physical appearance of the rock from the original state also to do what? To change. Therefore, the characteristic of the mineral content in those rocks, and also their physical appearance. Now, we had looked, in the previous lesson, we looked at the characteristics, because we said different minerals have got different mineral content, and they have also different characteristics. Therefore, those initially characteristics that we knew about the igneous rocks, the same time about the sedimentary rocks, they are going to be changed. The chemical composition of the mineral shall change. Thereafter, the characteristic of the rock will also change. Now, when the mineral composition of a rock changes and the physical appearance, that is the characteristic, changes, therefore we are going to get a different rock structure. This rock we are talking about is simply metamorphic rock. When these rocks have been metamorphosed, they are going to change. How or what happened during the process? We will look into the chart, and then we'll be able to understand how this is formed. Let us quickly look into our chart so that we'll be able to understand. Now, this is our chart that we are looking into it. It is explaining on how these sedimentary rocks are formed. The metamorphic rocks have been formed after the sedimentary and the igneous rocks being subjected to great heat and pressure. There will be a resultant formation of this rock. Therefore, this is just part of the structure of the earth, and in the structure of the earth, we'll have to remember this is just the surface of the earth, and then these layers made up the we call them this is where the mantle is, the mantle, and then it is in the upper mantle that magma, the magma chamber may be formed. And therefore, when magma is formed, remember magma is a molten rock. It is actually in fluid form. Therefore, what is it going to cause? This magma, remember, it bears the characteristic of the interior temperature of the structure of the earth being at 5,000, ranging from 3,000 to 5,000 degrees centigrade. This one makes the surrounding rocks in the mantle to be heated up. And as they have been heated, therefore, the pressure from the overlying burden, that is the continental crust, from the continental crust, the pressure from the overlying rocks of the continental crust are also going to release some pressure. And when that pressure comes, it is going to meet into the mantle where some rocks which are rigid, they are very solid, are there because of their formation. Suppose they are igneous rocks or they are sedimentary rocks. Their characteristic will quickly begin to change. Their appearance will change. And therefore, the metamorphic rocks surrounding this region will have a new form. Therefore, the metamorphic rock will begin to be formed in these zones where the heat has happened to bake the surrounding rocks. In the long run, making the general change of the metamorphic rocks, having new characteristic and appearance. We'll be able to find out the rocks that have been formed as a result of this. Let's look at the second part. That was part number 1, in which sedimentary rocks, metamorphic rocks, where metamorphic rocks are formed. Part 2 They are also formed when the tectonic process of the continental crust causes the collision and the friction on the horizontal pressure. As a result, this brings those rocks to have a new structure. We are able to see they are formed when tectonic processes occur, and some of the tectonic processes occur where? That is on the continental crust. That is where those rocks are, on continental crust. What will happen? This will cause collision. The forces will cause collision and friction. Friction will also be created. Friction and collision will relatively generate pressure on horizontal rock surfaces. It will generate pressure on horizontal rock surfaces. And remember, this friction and collision is acting on the sedimentary rocks, and therefore it will result into the formation of the new rock structure. As a result of the squeezing, the formation of a new rock, of a rock that is known as metamorphic rock, will be formed. That is the second way over which these type of metamorphic rock are formed. The third way, and that is the last bit of how these rocks are formed, they are formed when they are heated up. These rocks are formed, metamorphic rocks are formed when the rocks are heated up by intrusion. As we have already seen, the intrusion of magma. The intrusion of magma into the surrounding rocks. When the magma is heated and then it is actually intruded into the surrounding rocks, and those surrounding rocks are already known as igneous or sedimentary rocks on the earth. This will result into the process that is known as contact metamorphism. It will result into a process that is known as contact metamorphism. And this process of contact metamorphism, because of these surrounding rocks, they are able to, they are actually closely packed together and they contact each other. In the process of contact metamorphism, they are going to lead into the formation of a new rock. A new rock structure or new rock will be formed, and that rock it will be referred to as a metamorphic rock. It will be referred to as a metamorphic rock. That one will require that we are able to look again into the charts so that we are able to consider how the third part, when the rocks are heated by intrusion of magma into the surrounding rocks, therefore leading into those rocks that are around in the area, because they undergo what we call contact metamorphism, they are going to result into the formation of a new rock that is referred to as metamorphic rock. Let's look into the chart shortly, and then we'll be able to move. Now, this is our second chart that we are going to look at. We are still looking into the formation of the metamorphic rock. These are rocks which are already laid down in strata. These are the layers of rocks. These rocks are already in layers. These represent the layers of rocks. And these rocks are going to be subjected to great heat and pressure. These are just the forces that we are seeing here. This is sedimentary rocks. When they are subjected to pressure, then under that heat and pressure, they are going to strain and crumble in this manner. As they crumble, you will find that they will be squeezed and squashed so that the new characteristics are going to be found along the bedding planes of these layers. And therefore, obtaining this new characteristic, it is going to transform this rock or to metamorphose this rock into a newly formed structure that we referred to it as a metamorphic rock. This is how the metamorphic rocks are formed. They are formed using the three processes. That is where the heat is going to play a greater part in this part. Then, after looking at these processes over which metamorphic rocks are formed, we are going also to look into the types of metamorphic rocks. We'll be able to look into the type of the metamorphic rock. Let's look at the type of metamorphic rock. There are actually three basic types, not three. There are two basic types of metamorphic rock. They are going to be classified according to the mode over which they are formed. Therefore, these two basic types, when we consider the mode over which all of them are formed, we are able to find out that all of these metamorphic rocks have been formed as a result of the great heat and pressure after they have been subjected to great heat and pressure. Therefore, they are going to lead us into the formation of the foliated rocks. We call them the foliated metamorphic rock. Foliated metamorphic. These are the rocks which have already been laid down in strata, but they have unique characteristics. Their strata is found in bands, or they are banded as a result of their formation. That is unique in their appearance. When you look unto them, even using the lenses of your eyes, you'll be able to find these rocks. They have bands, and bands are simply small lines or strains of lines that can easily be seen on the rock just by the physical appearance of the eyes. This is where we call them the foliated metamorphic rocks, and this one, they have been produced as a result of them being exposed to direct heat and pressure. When you expose them to direct heat and also you expose them to direct pressure, therefore they will be resulted into foliated metamorphic rock, and this gives us a type of metamorphic rock. And the best examples here that we can be able to find them and can easily see them, examples of the foliated metamorphic rocks include gneiss. We have gneiss. We also have the phyllite. Then we have schist. And lastly, we have the slate. gneiss, phyllite, schist, and slate are the best example of the foliated metamorphic rocks. Why? Because their formation have been resulted after them being exposed to direct heat and pressure, therefore making what we call bands, or they are transformed into banded that can easily be seen by our eyes, therefore giving rise to gneiss, phyllites, schist, and slate as our best example. The next part is non-foliated metamorphic. We have the non-foliated metamorphic. Non-foliated metamorphic, this is also another type of rocks, of rock and metamorphic rock that are formed when heat is high but pressure is absent. They are only subjected to heat, and that is relatively high heat, but making pressure to be absent or less pressure. When these rocks are exposed to high heat and less pressure on all sides, this prevents the dominant minerals from having changed in it. Therefore, the mineral content that will be found in this rock will be able to realign themselves. Still, as they align themselves, they will be undergoing what we call recrystallization. Recrystallization of those minerals. The minerals will be recrystallized, now breaking out from the bands, and then they form an overall. They form an overall strong or strong and more dense rock that will be formed. And this dense rock will have a given appearance because of its density. It is very stronger. It is very strong, and because of its density, it appears to be dark in color. And that one will make us to know a type of rock that is going to be formed. It will have no bands, therefore. There will be no bands. It will be clearly a dark and without bands. That is why we call it non-foliated metamorphic rocks. And a good example of this type of rock is the obsidian. We have obsidian, and then we also have the dark colored rock that is known as breccia. These are the examples of these rocks. When you look at them, they are dark. They are dark, and they have no bands. They have been formed as a result of them being exposed to high heat with less pressure, and their mineral content are recrystallized, or they undergo the process known as recrystallization of the minerals, and then they are making their overall structure to be very much strong and having a denser quality, bringing it to have some dark colored, giving us an example of the obsidian and the breccia rock. Therefore, these are the two types of metamorphic rocks. We can also classify them further. We can further classify them into unique contexts so that we are able to find each of them placed in their rightful category, and perhaps we'll be able to know their uses. Classes of This now can bring us to the classification. That is classification of metamorphic rock. Having understood that the metamorphic rocks are rocks formed as a result of them being subjected to great heat and pressure, and their overall characteristic and the mineral content changes, therefore they are going to be classified into three major classes according to also where they are formed. We have the first class, that is, we call it the contact metamorphism. We have it called contact metamorphic. Contact metamorphic. Sometimes it is also referred to as local. That is one class. And these are the just type of rocks or metamorphisms that have undergone their change in specific localities. They have undergone a change. That is in specific localities. That is why we'll call them contact metamorphic rock, and they bear their local name depending on where they are found, because they often occur near the igneous intrusion. At that particular process, they normally occur, that is near what we call the igneous intrusion. And the kind of intrusion we are talking about, remember, it is magma. When this magma is superheated, the minerals in it, the mineral content in that original rock will be transformed, and that one will lead into the formation of the neighboring rocks, will be baked. The neighboring rocks will be heated or now baked. As a result of them being baked up, they will form a tough, fine-grained rock. Tough, fine-grained rock that is known as hornfels. In that process, you will find that this type of a rock that is known as hornfels, it just works within the local range of the specific locality. That is, it happens near the igneous intrusion, that is specifically magma. When magma is superheated in the process of contact metamorphism or contact metamorphic, therefore the nearby rock, the local rocks are baked, and when they are baked, they change their characteristic and produce a tough, fine-grained rock that is known as hornfels, as a best example of the contact metamorphic rock that is produced as a result of the contact metamorphism. That is the first part or the first class of this metamorphic rock, and we have seen an example is the hornfels. We are moving to the second one. The second one is referred to as a regional metamorphic rock. We refer to it as a regional metamorphic, and simply it is a type of rock that has been formed as a result of metamorphism of its mineral content. It is the mineral content and its texture that have changed over a wide range, over a wide area, that has resulted into those sediments that were buried down, and they were buried associated, their burial was associated with the plate tectonics, and therefore will result into the regional metamorphic rocks. They are simply looking at the mineral content. That is now the mineralogy, the mineral content of this rock. We refer to it as the mineralogy. Therefore, the minerals are the ones that are going to be changed after being subjected to the great heat and pressure that has resulted in a particular region. And that heat was generated by a close association. It is associated with what we call the plate tectonic activities, or the plate tectonic force. We will look into it later and how it affects the rock. Now, the mineral content, after being subjected to the heat and pressure that has resulted from tectonic force, I will just give one. An example is the earthquake. In those regions, over a period of time, it will result into the rocks changing the texture. Now, it is the texture that will change, but not the color. Texture, when the texture changes under great heat and pressure, you will find that there will be a new formation of a series of rocks. For example, the series of rock that will be formed. One example was the slate. Slate, if the texture will change, will lead to the formation of the phyllite. And then when the texture of the phyllite changes, it will lead to the formation of the schist. And when the texture of schist is going to be changed, is going to result into a formation of a rock metamorphism that is known as gneiss, and this one is happening over a wide range. Remember, this is showing an increasing heat and also pressure that has resulted from the plate tectonic force, such as volcanic activities and earthquake. The intrusion of the magma will spread over a wide region, making now the rocks that were in contact together, we now refer to them as regional metamorphic. They have undergone what we call a regional metamorphic, basing on their mineral content. After being subjected to great heat and pressure, their texture changes. And as their texture changes, there will be a series of the formation of the rock in this manner. This slate translates into phyllite, phyllite translates into schist, and then schist translates into a new series of rock that is known as gneiss, and that brings us to the understanding of the second part or the second class of these rocks. I'll mention also this, that regional metamorphism can be described and classified into metamorphic, that is metamorphic zones, the zones where temperatures and pressures have maintained one constant in the process of orogenic terrain, and that one will make them very unique, and therefore giving us a new class of metamorphic rock that is known as regional metamorphic. The last class we will look into it is the hydrothermal metamorphic. Hydrothermal metamorphic or metamorphism. Hydrothermal, as the word says, word hydro means there's some elements of water. Thermal means heat. Therefore, when we break into our understanding of this, the hydrothermal metamorphism occurs at the boundaries of oceanic plates. This one occurs in the boundaries of the oceanic plate. And the oceanic plate, be able now to understand, it is the plate that carries water mass, such as the ocean, seas, and lakes. When these plates are still moving apart or they move away from each other, it allows the seawater. This allows the seawater. When the seawater is allowed, it is percolated into the zones of the crust, and then through the process of the hydrothermal, this water is going to be superheated. The water are going to be superheated by the magma in the interior of the earth. And then this water will still percolate as they flow into the continental crust through the oceanic crust. It will make that water to react with the mineral content that is found in those in those rocks. Such mineral content that will be very much reactive as a result of the superheated water include the iron that is found in the rock. We can also look at the nickel. Nickel is also a mineral content that is found in those rocks, and then we will have silver. And eventually we have gold and cobalt. Gold and cobalt. Such minerals, when the superheated water is going to reach this mineral, such as iron, nickel, silver, gold, and cobalt, it will result into the formation of a new rock. Because, mark you, when gold is being exposed from the earth, when gold is subjected to superheated water, it now changes its color. The impurities will be removed, and those impurities that were embedded on gold will now be flushed out. When you weigh out those impurities, because that process works still underground or in the continental crust, it will result into the formation of a new structure of a rock or a mineral that will now be able to define a rock that we are talking about. The hydrothermal is called the copper. For example, the copper ore will be formed, and from the world source, you'll find that copper has been mined in the country of Cyprus for several years. As a result of the hydrothermal metamorphism, that ore of copper deposits enlarges itself into the region where it is found, and therefore where copper is found, we cannot be able to find cobalt, silver, and nickel because they have been replaced into the transformation resulting into the copper, and that one will give us a new characteristic of a rock. Therefore, lastly, we will be able to look into the characteristic of the metamorphic rock. The general characteristic of the metamorphic rocks. There are very few characteristics of metamorphic rocks that will distinguish them from other rocks. Now, because of the mineral content or the mineral grain, they have grew together tightly during the process of metamorphism. They are generally very strong. They are very strong. Why? They are very strong because the mineral particle or the mineral particles that were found in them, they grew together with the other minerals tightly in the process of recrystallization. In the process of recrystallization, you will find them having the very fine grain. They will have very fine grain that cannot be easily be broken, therefore giving it a characteristic of being strong. They are generally strong, and because of their strength, you can find their use somewhere. Characteristic number 2, they are made of different minerals. These rocks are made of different minerals. Or you can also say mineralogy. They are made of different kinds of minerals than other kinds of rocks. When you compare metamorphic rocks and other kinds of rocks, these ones are composed of different mineral. One rock can have various minerals, and an example is copper. The ore of copper and iron is composed of various minerals in it. And then number 3, we'll be able to find that they often show sign of stretching. They can easily stretch. They can be stretched. Or they often show sign of stretching. Let me use the right word here. When they are stretched, they can also easily be squeezed. And in the process of them being squeezed, they can easily have they can easily have different uses depending on their ability. That means when you take a mineral content of this kind of rock, for example, iron. Iron is a mineral that is found in the rock. When you strike iron, it can easily stretch, and in the process of stretching, it can lead into the formation of any other substance that you want as you hit continuously in one particular point. It can stretch and curve up. That gives it a general characteristic, and therefore having looked onto this, we'll be able to look at various types of rock on the chart, and then finally we will wind up the metamorphism of various rock. I have picked very few examples here. The protolith is the parent rock, and then the metamorphic that is formed is simply means the new structure or the new appearance of a rock. When you look onto this chart, we are able to sample out the original rock such as quartz and sandstone. When sandstone is metamorphosed, it will lead to the formation of a new rock that is known as quartzite. Also, when the quartz itself is metamorphosed, it will change into quartzite. Quartzite has different characteristics from quartz, or even also the sandstones. Also, when we look at an original rock such as limestone, I hope you understand limestone is a rock that is used to extract cement. When it is metamorphosed or changed into a new rock, it will form a new rock that is known as marble. Marble will have new characteristic than limestone. Eventually, when we look at shell will be able to form various metamorphism depending on the degree of heat that is subjected to it. We have been able to look at a series of heat. When you increase heat, we'll find hornfels type of rock are formed, and then slate can also be formed, schists and gneiss. These are various formation of the metamorphism of the rock as we look onto it. Generally, as we wind up this part of the metamorphic rock, we'll be able to look at various examples. Of very numerous rocks that we can find in the category of the metamorphic rock. We have amphibolite. Then we also have hornblende. Another examples is plagioclase. And then we also have quartzite. We have slate. We have gneiss. We also have schists. I've already mentioned marble, limestone, and phyllite. These are the examples of all the metamorphic rocks when they have been formed through various processes. And if we can give them class, these cannot easily be classified because one will have almost two or more characteristics that come from the initial protolith, and therefore we will give their general examples so that we are able to understand them. But when we go to the chemistry of their mineral content and how they are formed, we can have them be classified in different categories. I would like to wind up by giving us a brainstorming question. Let us look at the brainstorming question here so that we are able to capture apt. Question 1 will simply ask us what is metamorphic rock? Then part B will give us a state, that is 3 formation. Of metamorphic rock. And then lastly is explain classes of metamorphic rock. This will help us to go through the topic of metamorphic rock, and then having them in mind, we'll be able to respond to them, and over that we'll be able to get feedback from you. You can find this is for your research. You can extend it to and then communicate back to us through the email that is provided, and we'll be able to get the feedback positively. Have a good day. Thank you.